This is section 4.4, trigonometric equations of the quadratic type. Let's go to the next slide. Here's number one. It says find all real numbers in an interval that you see there that satisfy the equation. Round your answer to the nearest tenth. That's if necessary. And for number one, we're looking at sine of negative x equals cosine of x. It's going to help if you have the unit circle right next to you as we go through this video. We're going to be applying a lot of algebra in these problems. And so here's what we do for the first problem. I'm going to go ahead and take in consideration that sine of negative x can be written as negative sine of x because sine is an odd function. From here, I'm going to divide both sides by negative cosine of x. Once I do that, I end up with the following. And notice that at this point, I end up with some equation that looks very similar to the previous sections. So I need all the real numbers of x to satisfy this equation that are in the interval between 0 and 2 pi, not including 2 pi. And it turns out to be 3 pi over 4 and 7 pi over 4. Remember, tangent is negative in quadrant 2 and quadrant 4. Let's go to number 2. 2 tangent squared of x equals tangent of x. So I'm going to move everything to one side, mainly the left side, and I have 0 on the other side. At this point, I'm going to take this binomial, and I'm going to take out the common factor, which is tangent of x. This is what I get. From here, I notice that I have a binomial and a monomial, and the product is equal to 0. So I can apply the zero product property, which you learned in Algebra 1 or 60. So this is what I get once I set the first factor equals 0, second factor equal to 0. From here, I know that tangent of x is equals 0 is at x equals 0 and pi. So I'm done with this part of the equation. Now I need to do this part. So from here, I'm going to isolate the tangent of x, and this is what I get. From here, if you look at the unit circle, you're not going to see any ratio that corresponds to tangent that is equal to 1/2. You have for other trig functions, but not for tangent. But we do have an answer, but it's just not one of those special angles. So all we need to do, if I want to find an answer, I need to use my inverse function. And remember, tangent inverse is always going to give you an answer either on the first or the fourth quadrant. From here, since you have a positive ratio, you know that the calculator is going to give you the angle on the first quadrant. So this is what you get. So the answer on the first quadrant, you do this and you end up with 0.5 approximately, and you round to the nearest tenth. Make sure that you are in radians. From here, again, you also know the tangent, just regular tangent, is also positive in quadrant number 3. So you have to compensate for that. The calculator is not going to give you the answer on quadrant 3. It's only going to give you the answer in quadrant 1, which we just found. So how do we end up with the answer in quadrant 3? All we need to do is take this answer, and you're going to have to add pi to it. Why? Because we're using reference angles. Okay, and I can clarify this a little bit more in class, but you should be able to follow what we're doing here. So once we do that, we end up with 3.6. So my answers, I'm going to rewrite them using set notation, which are going to be these 4 values, 0, pi, and what you see here. So that's the answer to number 2. Let's go to number 3. So here's 3. Same directions as number 1 and 2. Number 3 is 6 sine squared of x minus 2 cosine of x equals 5. What you're going to be doing in this problem, actually what we are going to be doing in this problem, is we're going to have to apply the quadratic formula, but this problem will be done in class. Let's go to number 4. So we're looking at that sine squared x minus cosine of square x equals 0. This, you might be tempted to say that the left side is equal to 1, but of course it is not. So this is what we do. There's a lot of things that we can do. I'm going to go ahead and do this. I'm going to set sine square of x equal to cosine square of x, because I can move this expression to the other side, and this is what we get. At this point, something that we did on number 1, we're going to use here. I'm going to divide both sides by cosine square of x. And once I do that, this is what I get. From here, again, there's several things that you can do. I'm going to go ahead and choose to go this way. Move the 1 to the left side, and I have this binomial. And notice that I have the difference of perfect squares. So I'm going to factor this. Once I do that, I get the following. This is binomial times binomial equals 0. So I can apply the zero product property. Set the first factor equals 0, and I get and solve for x, and I get tangent of x equals 1. And the second one, from here, I end up with for this x value, I end up with pi over 4, 5 pi over 4, refer to unit circle, and then here is 3 pi over 4 and 7 pi over 4. So I express my answers in set notation, and this is what I get. Let's go to number 4. So number 5, excuse me, let's go to number 5. So what I'm going to do is I'm going to move this to the left side, and this is what I get. At this point, I have a binomial, and I notice that I have a common factor of tangent of x. I pull it out. This is my new expression on the left hand side. Again, I have product of two factors equals 0. I can apply the zero product property, and this is what I get once I set them equal to 0. From here, I am going to solve for x here, and I end up with 0 and pi for this left equation. Now for the one on the right hand side, I'm going to isolate the secant square of x, and once I do that and I take the square root of both sides, this is what I get. But I don't want to work with secant of x. I much rather work with cosine of x, so I just take the reciprocal using the reciprocal properties. From here, reciprocal identities or properties. From here, what I'm going to do is I'm just going to see where cosine of x is equal to positive radical 3 over 2 and also negative radical 3 over 2, refer to unit circle, and these are all the angles. Combine these two answers, and this is what you want to express as the answer for number 5. All these angles in order. Let's go to the next slide. So here's number 6, same directions, but notice that this just looks different. But if you refer to section 3.4, and you should recognize that we can apply sign of a difference. So this is what we get on the left hand side, and then bring over the right hand side, negative a half. From here, let's talk about this before we continue. Notice that I have sine of an angle, and the ratio is a negative number. Remember, sine inverse is always going to give you an answer either first or fourth. Now, if you punch it into the calculator, you know it's going to give you an answer in the fourth quadrant. But you know that sine is also negative on the third quadrant, so you have to compensate for that. The calculator is not going to give you the answer in the third quadrant. So this is what we have to do. First, let's find the answer that is coming from the third quadrant. Okay, and this is what we're going to do. We're going to set the angle that you see there. Let me get my pen. And equal to the angle in which sine is equal to negative a half, which turns out to be 7 pi over 6. Okay, so now let's look at the one that is on quadrant 4. And again, if you ask the calculator to do this for you, it will give you this one. It's never going to give you this one. We can talk about this a little bit more in class, but here we go. Answer that is on quadrant 4 is set the angle equal to 11 pi over 6. From here, notice that this is coterminal to negative pi over 6, which is okay. From here, you're basically going to solve these two equations for x. So if you look at this one, you can move the 7 pi over 6 to the left, move the x to the right, and this is what we get. Go through a little bit of algebra. We'll leave that for a second, but same thing here. Move the 11 pi over 6 to the left, the negative x to the right hand side, and this is what we get. Now we go ahead and simplify. This gives me x is equal to negative pi, and this gives me x is equal to negative 5 pi over 3. Now, if you look at these two answers, they do not fall within the restriction that we need to satisfy. In the given interval. So what we need to do is we need to find angles that are coterminal to both of these answers. An angle that is coterminal to negative pi, that is falls within this restriction, it turns out to be pi. This one is actually pi over 3. So the two answers for number 6 are here. Let's go to number 7. This looks different, but all we need to know is rules of exponents, which you have seen in Algebra 1, Algebra 2. We're just applying the trigonometric ratios with those rules. So notice that I'm just going to rewrite this 4 as 2 squared. And once I square that, I multiply times the power that is already there. So I have the following. And on the left-hand side, I notice that I have the same base. And if you remember the properties of exponents, if you're multiplying and you have the same base, all you need to do is add the exponents. So once I do that, I'm going to write the single base of 2 and add these two exponents. And that's what you see there. From here, we're just basically going to use a little bit of logic. In order for this expression to be equal, notice that the base is 2, the base 2 on the right-hand side. For them to be equal, the exponents have to be equal. You did this in Algebra 2 or 80. And again, if you want me to clarify that in class, I'll be more than happy to. But let's continue. So I'm just basically going to drop the bases and then focus on the exponents. Or you can just take the natural log of both sides and you apply the properties of natural logs and you end up with the following. From here, this equation looks a little bit more friendly than what you had there. But let's continue. I am going to move the cosine of x to the left hand side, and I'm going to work with this trinomial. Once I have this trinomial, I'm going to be applying my factoring techniques. Once I do that, I get the following for this trinomial. This is the factor form. Notice if I was to multiply these two binomials, I get the original trinomial that you see here. Then I apply the zero product property, and I solve for x. This gives me negative half, this gives me positive 1. I look at my unit circle, and I get, for negative a half, I have 2 pi over 3 and 4 pi over 3, which are angles in quadrant 2 and 3. And then cosine of x is equal to 0, cosine of x is equal to 1 at x equals 0. Set notation, and we are done with number 7. Let's go to the next slide. Here's number 8. It says find all values of theta in the interval between 0 and 360, not including 360. Satisfy each equation. Round to the nearest tenth of a degree if necessary. So let's look at 8. So basically what we are going to be doing in this problem, we're going to be applying a formula used on section 3.5, which is, if you look at the half angle identity for sine, and notice that this is squared, we're going to be able to substitute that for 1 minus cosine of theta over 2. And then at this point, I'm going to multiply this 2 times this expression, and notice that these two cancel out, and I'm left with this. I am going to add cosine of theta to both sides, and I get this. Isolate the cosine of theta, and I get cosine of theta is equal to a half. What cosine of theta is positive on quadrant 1 and quadrant 4, so the angles that satisfy this equation in degrees are 60 and 300 degrees. Let's go to number 9. So this one I'll be doing in class. Let's go to the next slide. So here's 10, same directions as the previous slide. So we're looking at what you see there, sine square x plus 9 equals 6 sine x. First thing that I'm going to do is I'm going to move the sine 6 sine x to the left hand side, and this is what I get. At this point I have a trinomial. I am going to factor this. This is what I get. From here I'm going to set just one of the factors equal to 0, because basically it's going to generate the same answer if you set the factor twice. And then this is what you get once you solve for sine of x. Sine of x is equal to 3, and as you may already know, this produces no solution. Let's go to number 11. This one will be done in class. This will be the last one, 12. I have this trinomial equal to 0. I'm going to basically factor this. Once I do that, this is what I get. Cotangent square of theta minus 1, cotangent square theta minus 3. And again, you can check this, FOIL these two binomials, and you get the original trinomial. From here, I am going to set these factors equal to 0. And this is what I get. At this point, I am going to basically do a different approach. I'm just going to solve for cotangent of theta on both equations. And then at this point, I'm going to get rid of the power on both of them. So I'm going to take the square root of both sides. Once I do that, this is what I get. Cotangent of theta is equal to plus or minus 1. On the other one is cotangent of theta equals positive and negative radical 3. And then if you refer to the unit circle, where do we have those angles that satisfy both of these equations? And here all the angles that satisfy those equations. And then just put them in order, and this is the answer. Notice that they are in order. This concludes the video.